let's talk about page T. These two problems on page number 42 and 43. I'll be honest with you, in all the years I've been teaching chemistry, I have never heard of this law related to the diffusion of gases and their rates. But hey, never too late to learn something new, right? And the formula isn't really too hard to use, a little different. We have some square roots in here. It does tell us that the rate of gas A, notice that the mass, the square root of the mass, molar mass, is on the bottom, okay? So it's inversely proportional. RB, put the mass up here on the top. So this is the way we set up inversely proportional equations. Let's look at problem 43 first. It says a sample of helium sample 42, example 42. Which gas, hydrogen or oxygen, diffuses faster and at what relative rates? Okay? So, hydrogen, let's make that H. The A is going to be H2, and B is going to be the O2. So we can look up hydrogen on our periodic table, and I have one right here. And hydrogen's mass is 1, but notice this is H2, so the mass is actually 2, okay? Square root of 2. And then the mass of B, oxygen's mass is, if you look at your periodic table, basically 16, okay? But I have 2 of them, so it's 32. And so I'm going to let you finish that. Use your calculator, get the square root of both of those, take the numerator, divide by the denominator, and basically what that's saying, you get one number then, okay? And what that's saying is the rate of hydrogen is, I don't know, whatever that works out to be, 3.5 times as much or 5 times as much as this, okay? So I'll let you finish that one. Let's talk about number 43. Let me get a different color here just for the fun of it. We're going to start with the same root formula. It says a sample of helium effuses 2 times faster than another gas. We don't know what that gas is, but let's do R. I'll abbreviate it helium, R, U for unknown. All right? And we're going to say the mass of the unknown, and this is the mass of helium. Now the thing about helium is it's not a diatomic, okay? So we can just look at the periodic table and get the mass of that is 4. What's another fact that they give us here? They say that the rate of helium is twice this rate. So we have another piece of information here. RHE equals 2 times the rate of the unknown. Okay? And what we're asked to solve for is what is the molar mass of the other gas. Now, if you remember any of my videos from back when we do ratio problems, you know that to find one quantity when we have a ratio is we can cross multiply these two sides of kitty corner from each other, divide by this one, and we'll have this. So I'm going to set up a little formula here that says mu equals, I'm going to cross multiply, RHE, should be subscript, times the square root of MHE divided by RU. Are you with me? So Mr. Anger, this is not looking easier. Hang on. Now we're going to do some substitutions. We know this is equal to this. So I'm going to substitute that. Okay? So 2 times RU times the square root of 4, because 4 is the mass of helium. All right, divided by RU. Now watch what happens. Because of this, and this is cool, all right, this happens a lot in chemistry and physics, and we do these substitutions so that something will simplify. Look at that. We don't know that rate, and we don't need to, because it just cancels out of the equation. Isn't that cool? And you know what the square root of 4 is. It's 2. Yay! So now I have 2 times 2 is 4, and that is the square root of the unknown mass. We're almost done. One last step. How do we undo a square root? Mr. Anger, I forgot how to do that. That was way back in Algebra 2. Yep. We'd square both sides. Okay? When you square a square root, it just pops out. So then I have the mass of the unknown equals, oh my goodness, we got this far. I can't do the last step for you. You need to solve that, okay? But then show your work, put all of these steps down, and impress your teacher that you know all of these steps. You did the last step and you got the answer. Then when you get to number 44, we have 4 different types of gas. And basically you're saying which of those gases, if you added up how many grams for 1 mole, would you have? For instance, looking at that first one, nitrogen is 14, okay? And then hydrogen, each one is 1, so 14 plus 4 is 18. So if this number works out to be 18, then it's likely to be NH4, okay? So you check the mass of each of those 4, find which one is the closest to what you got there for 43. So it's a little different. I don't think you'll have on quite that hard on the checkup and self-test, but they do want you to know this formula. All right, good luck.